So in this video, we're going to take a look at how to find some information between 2 points. So that's the gradient, that's the steepness, the midpoint between 2 points, and then the distance in a straight line between those 2 points. So let's take a look at an example here. Let's have a look at B, right? Okay, we've got 2 points, 6, 13, and we've got another point here, look, 10, 21. Now, if we want to find the gradient, the steepness, well, the formula for the gradient is going to be the change in y divided by the change in x. So we need to take a look at the change in y first of all. Well, if we think about it, from the first point to the second point, our y coordinate change is from 13 to 21. So that means it's going up by 8. And then the x coordinate change is going from 6 up to 10. Well, that's a difference of 4. So the gradient is going to be 8 divided by 4, which of course is 2. So the gradient, we can just use that simple formula, the change in y divided by the change in x. Okay, now we're going to think about the midpoint. Well, let's think about the 2 points again, and let's think about what the middle of those 2 points is going to be. So let's start off by imagining those 2 points, right? Okay, the first one has an x coordinate of 6, the second one has an x coordinate of 10. So what will the midpoint of those x values be? Well, it'll be in the middle of 6 and 10. Well, clearly that is going to be 8. Now, if we consider the y values, we've got 13 and 21. Now, it might not be obvious what the middle of 13 and 21 is. So there's a simple trick. You can add them up, 13 plus 21, and that's going to give us 34. And then we can divide that by 2. So 34 divided by 2 is 17. So it's like finding the average between those points. But either way you think about it, we're going to have that coordinate point of the midpoint there as 17. Okay, so midpoint 8, 17. The last thing we've got to do is find the distance between them. So let's consider these points again. And this time, let's draw a little picture to help us. So imagine we've got 6, 13. Well, actually, 10, 21 would be a little to the right and a little up, wouldn't it? Right? 10, 21 there. So we've got to find the length of that line. Now, we can do that because we could consider it as part of a right-angled triangle, right? If we want to find the length of that line and we have a right-angled triangle, well, we could use Pythagoras. We've already worked out from when we did the gradient that the change in y is 8. And we also found from that the change in x is 4. So we have the information necessary here to think about this and to work out that length using Pythagoras. Now, Pythagoras says that that hypotenuse, and let's call it c, squared is the sum of the other two sides squared. So if we label that with a little c, look, c squared is going to be 4 squared plus 8 squared. So if we do this nice and simply, well, 4 squared is 16 and 8 squared is 64. Now, if we add those together, we're going to get 80. So c squared is equal to 80. And now if we square root that, we're going to end up with our length. Okay, c is going to be the square root of 80, which, if we want it as a decimal, is going to be 8.94. Okay, now they're just going to be a generic units because we haven't got any centimeters here. So there we go. We've got the answer. We've got a gradient of 2. We've got a midpoint as well of 817. And we know the length between those two values is 8.94. Okay, so let's do another one, right? Let's have a go at a more challenging question, all right? So why not pick something like, let's look at I here, okay? We've got some negative coordinate points, it's gonna help, okay? So this will be a little tough. Let's do exactly the same process though. So let's call the first one A, and that is gonna be -6, -11. And let's call the second coordinate point b. So minus 9 minus 5. Now, we'll be a bit more formal this time. You've had a sort of an explanation as we've gone along as to why things are working. But let's start off then by looking at the gradient. Okay, now there is a formula for gradient. Okay, we could use that. As well as having the change in y over change in x, that formula is y2 minus y1 over x2 minus x1. So we could consider this with the formula, but it's going to give us exactly the same answer if we just look at the differences between the two. Now, maybe we would say that, and label this up, x1 is the minus 6 and y1 is the minus 11, x2 is the minus 9 and y2 is the minus 5. So we could think of it like this. Well, this is going to give us minus 5 minus a minus 11, all divided by minus 9 minus a minus 6. Now, if we were to do that, well, that would be minus 5 plus 11, which is going to be 6, all divided by minus 9 minus minus 6. Well, that's going to be moving up 6 places from minus 9, which is minus 3. So that will be a gradient of minus 2. So that's a more formal process. That will work anytime, regardless of if we're negative or positive. Right, let's move on to the midpoint. Now, for the midpoint formula, we just have to add them up and divide. We alluded to this in the last example. So the midpoint will be x1 plus x2 divided by 2. And then the average y coordinate will be y1 plus y2 all divided by 2. So if we work that out, we are going to have, I'm just simply putting the numbers in, x1 plus x2 is going to be minus 6 plus 8 minus 9, all divided by 2. And then the y coordinate will be minus 11 plus 8 minus 5, all divided by 2. If we work that out, minus 6 plus a minus 9 is going to be minus 15. And then minus 11 plus a minus 5 will be minus 16. So if we work those out, we'll have a midpoint of minus 7.5 minus 8. Okay, finally, let's move on to that gradient, the length of the line. Now, we're going to be using Pythagoras, okay? But if we call the length of the line L, well, if we think about the change in y, well, that's going to be y2 minus y1, and we're going to square it because it's Pythagoras, plus the change in x, which is going to be x2 minus x1 all squared. Now, if we just had that, that would give us the square of the length. So I'll square root it, and that will give me that formula. So we could just straight use that formula there, look, and that's going to work every single time regardless. So let's put those numbers in again. We are going to have, well, y2 minus y1, we've kind of already done that in the gradient. That was 6, wasn't it, right? Okay, so that's up here, look. And the x2 minus x1, well, that was here, look. So we already know that was minus 3. So we could use our previous work to help us. So this is going to be the square root of 36 plus 9, which is the square root of 45. And if we just quickly jump onto a calculator and do the square root of 45, that is going to be 6.71. So we have the length, the distance between the 2 points, which is 6.71. We have that gradient of minus 2, and we have that midpoint of minus 7.5 minus 8. So hopefully with this video, you can understand how to calculate the gradient, midpoint, and distance between any 2